Lesson 23, Kinetic Energy. Our objectives are, as usual, to define what it is we're talking about, kinetic energy, and second, to be able to calculate an object's kinetic energy. So let's start with the definition. Kinetic energy is the energy an object has because of motion. Remember, energy is the capacity or ability to do work. In other words, when a force moves an object through a distance, and force equals movement. So kinetic energy is the energy an object has while we see the work being done. The symbol that we will use for kinetic energy is a capital K, capital E, and the unit, as we said in the previous lesson, for all energy will always be joules. The formula says that kinetic energy is a half, or 0.5, times the mass of the object in kilograms times its speed squared. Notice that the speed is in meters per second, and that's in red, because that's important. In everyday life, we usually don't have speed in meters per second. It's given in things like miles per hour. If we don't have speed in our basic units of meters and seconds, we will not get joules out for our unit. The answer will not be correct. You will want to put this formula on your formula card under mechanics next to your potential energy formula, labeling it kinetic energy. Let's take a look at our example. We are looking for the kinetic energy, so we put down our formula. We see that we need the mass, which in this case is 4 kilograms, and we need the speed or velocity, which we see is 30 meters per second. We have the proper units, so we can substitute. Notice that in this case, I didn't put the units in. Putting the units in will probably be a lot more confusing, so it's better not to do so. One important thing, though, is the fact that we are squaring the speed. That's a mistake that a lot of students make. They forget to square the speed, so make sure you do what the formula is telling you to do. So we need to take 30 and square it. We end up with 1800, and our unit for all energy is joules. And that's our final answer.